Welcome to the first in my series on air painting for modelers. In this video, I want to talk about the basics of the airbrush itself and the different configurations, controls, sizes, and to which task each type is best suited. To understand how an airbrush works and the different designs, it's interesting to look at their history, because as you'll see, today's airbrushes still use the same basic designs developed over a century ago. The first type of an airbrush was patented in 1876 by F.E. Stanley. Stanley's best remembered for the Stanley steamer. Stanley named his device the atomizer. His device featured an adjustable needle to regulate the amount of fluid. Stanley used a combination of the Venturi effect and Bernoulli's principle to accelerate the air through a constriction, resulting in an area of low pressure that would draw the fluid from the reservoir into the rapidly moving airstream. A closer look at the design reveals the similarity to the ever-enduring Paget Model H. However, most airbrush historians consider Abner Peeler to have patented the first airbrush. His device was patented as the Peeler Paint Distributor in 1882. It used an oscillating needle driven by a turbine to distribute the paint into the airstream. The basic design was refined and made popular by Liberty Walkup. The ultimate development of this design became the legendary and near-mythical Paget AB. His miniaturization of this design gave Paget his first patent. In 1892, Charles Burdick patented a revolutionary design that mixed the paint and air within the body of the device, creating the first internal mix airbrush. His was actually the first device to be patented using the term airbrush in the description. Shortly thereafter, Burdick was granted British patent rights. He moved to England and finally established Airgraph in 1900. During this same time period, airbrush and spray gun design quickly evolved along with familiar names like Thayer and Chandler, de Vilbiss, and Binks. Today, the vast majority of air painting tools are a variation of Burdick's design. Using Bernoulli's principle, a stream of rapidly moving air passing over a parallel fluid nozzle and needle causes a decrease in pressure, allowing the paint to flow from the reservoir into the airstream and become atomized. How and where the needle and nozzle are related to the airbrush body is the first characteristic we use to describe an airbrush design. If the paint nozzle and needle are located outside the basic airbrush body, it's referred to as an external mix airbrush. The classic example is the Paget Model H. If the paint needle and nozzle are located within the body of the airbrush, it's referred to as an internal mix airbrush. How and where the paint enters the airstream has a dramatic effect on the atomization. In the case of the external mix airbrush, the paint nozzle is positioned significantly in front of the air outlet. At this point, the airstream is already beginning to spread, reducing the effect of the lowered pressure over the nozzle and requiring a greater amount of air to effectively draw the paint. Here you can see the quality of the atomization produced by the Paget Model H. With the internal mix airbrush, the paint nozzle is parallel to the airstream with its exit located much closer to the air constriction. At this point, the airstream is pretty tight around the nozzle, making it closer to the area of negative pressure. You can see the significant improvement in atomization when compared alongside the result from the external mix airbrush. Another variation in airbrush design is how the paint's fed to the nozzle. This can either be from the bottom, side, or top. Airbrushes that feed from the bottom are known as siphon feed or bottom feed. Here the paint has to be siphoned upwards and requires a greater airflow over the nozzle to draw the paint into the airstream. Airbrushes that feed paint from a color cup located on top of the airbrush are termed gravity feed airbrushes. Due to the effects of gravity and pressure acting on the surface of the material, these airbrushes require less air pressure to draw the paint into the airstream, making it easier to control when doing fine detail work. Airbrushes that feed material from the side can have the characteristic of either gravity feed or siphon feed depending on how the color cup or bottle is constructed, as well as how much material is in the cup. In this case, the material is siphoned from the bottom of the color cup, but the siphon tube is located midway down the side of the cup. That means that when the material is above the height of the tube, atmospheric pressure acting on the surface of the material causes the cup to behave like a gravity-feed cup. But when the fluid level drops below the height of the tube, the cup functions more like a siphon feed or bottom feed airbrush. Most of the time, this effect is mitigated by the fact that these airbrushes are most frequently used by graphic artists with very light materials such as ink. The third major variation of airbrush design is how the air and paint are controlled. Airbrushes that use a simultaneous air and paint control are termed single-action airbrushes. When you depress the trigger on a single-action airbrush, you start the air and paint flow. Paint flow is adjusted through a separate needle adjustment. Single-action airbrushes can either be external mix like this Pache Model H, or an internal mix like this Badger 200. Airbrushes that allow you to control the air and paint independently with the trigger are termed double action. With a double action airbrush, you depress the trigger to start the airflow and then pull back on the trigger to regulate paint flow. The further you pull back on the trigger, the greater the paint flow. This type of action allows for much more control of the painting process. Airbrushes are also manufactured in a variety of needle and nozzle sizes to optimally handle different viscosity materials and create different pattern sizes. As modelers, we generally use paint. So with regard to material flow, I suggest a minimum nozzle size of 0.25 mm and a maximum of 1 mm. Nozzles smaller than 0.25 mm are more prone to clogging when used with model paints, and nozzles larger than 1 mm simply supply too much material for our needs. While the nozzle size can be an indicator of what viscosity material the airbrush can handle, the design, geometry, and how the components of the head work together determine how well any airbrush atomizes the paint and how the pattern is shaped. I'll be touching on these factors as we look at the different airbrushes and miniature spray guns. Airbrushes are also available in different form factors. The traditional style airbrush uses a button trigger controlled with the index finger. Trigger style airbrushes use a miniature variation of the trigger found on spray guns. The ergonomics of this type can be a bit challenging, especially if you're generally comfortable with a traditional style airbrush. In an effort to improve ergonomics, some manufacturers fit the trigger style airbrush with some sort of plastic hand grip. In my hands, I find this even less usable as the grips are generally too small for my hand, and the trigger's too short to accommodate more than one finger, so one finger winds up under the trigger. There are also two specialized airbrushes from Iwata that adopt a miniature spray gun form factor. The one-piece body casting on these two allow for an improved mechanical arrangement, as well as a proper hand grip, a longer trigger, and when combined with the more compact overall length, it just has an all-around better balance. I'll be discussing these further in the next episode along with the other miniature spray guns. If one type, style, or size airbrush did everything well, there'd be no need for such a wide variety. But the fact is, just like artists' bristle brushes, no single airbrush does everything really well. And in the next episodes, I'll be talking about which airbrushes or spray guns are most suitable for the different tasks that we typically use our air painting tools for. So long for now, and I'll see you next time.